Escape Unit 1 Applied Math. Let's begin. State one advantage and one disadvantage of using each of the following sampling methods. So the first sampling method is systematic, and systematic is really a sampling method where the sample is selected from the population with fixed or periodic intervals. So one advantage. So let me begin with the advantage. So one advantage of systematic sampling is that it's simple and quick to implement. And one disadvantage is data can be manipulated. Convenient sampling, an advantage, let me call it as an advantage. So convenient sampling is using participants that are readily available, and an advantage is that it's easy to implement. Also cheaper, or is it cost efficient? That's another advantage we could have listed. And disadvantage, obviously, is data is not random. Snowballing. So snowballing is when you ask your participants to identify other participants that could be surveyed and included in your sample. And an advantage, it helps to reach the researcher to reach difficult audience. Disadvantage, again, it's not random, and it could encourage biasness in the population, in the sample. Part B, the length of calls received by 50 agents at a call center is given in the frequency table. And we have a table there, length of calls ranging from 2 to 13. And we have our corresponding frequencies below. So group the data using a class width of 2 to construct a cumulative frequency table for the information given. So we begin. So length, and length of using X to represent that, and of course frequency, use F to abbreviate frequency, and in the final table, cumulative frequency. So we are told the class width must be 2. So let's start from the shortest length of call was 2. So 2 to 4. Make sure the class width is 2 to 4. So we look at how many calls range 2 to 4. So 2 to 4, with 2, 3, and 4. So the frequencies combined, 4 and 2, 6. 6 and 3, that's 9. Next, we have 5 to 7 calls. For 5 to 7, 5, 6, and 7, the frequencies, 9, 5, and 5. 5 and 5, 10 and 9, that's 19. Next, 8 to 10. So 8 to 10, 8, 9, and 10. At the frequencies 6, 5, and 4, that's 15. And then the last interval would be 11 to 13. And 11 to 13, the frequencies add to 3, 1, and 3, that's 7. So the cumulative frequency will start from the smallest value, which is 9. The first frequency, which is 9. Add 19, we get 28. Add 15, we get 43. And add 7, we get 50. And it's 50 agents, so we expect the cumulative frequency to add to give 50. Next, on the grid provided on page 7, draw the cumulative frequency curve to represent the information in the table constructed. At B part 1, you must use appropriate scales and labels. So this is our table. We're going to draw a cumulative frequency from this data in the table. So notice the length ranges from 2 to 13. The cumulative frequency goes up to 50. So let's label our graph. So the length of calls goes up to 13. The cumulative frequency and the vertical axis goes up to 50. I'll count by 5. So for using a 1 to 5 scale, so 10, 15, 15. Let's stop at 50. So when we're doing the curve, remember it's upper is the upper boundary. Is the upper boundary against the cumulative frequency. So we want to rewrite these values. So this is 2, subtract 5, that's 1.5. Add 5, let me use a different color. So that's 1.5. That's 4.5. Subtract 5. That's 4.5. Add 5. That's 7.5. Subtract 5. 7.5. Add 5 to the upper limit. Subtract 5 from the lower limit. Add 5 to the upper limit. So these are, we're plotting the upper boundaries. So these are the values we're using. 4.5, 7.5, 10.5, and 13.5 to the cumulative frequencies there. Alright, so 4.5 to 9 is our first point, and 13.5 to 50 is our last point, right? So our first point, 4.5 to 9, that's midway between 4 and 5, and 9 is thin line below 10. Next, 7.5 to 28, so midway between 7 and 8, and we'll go up to 28, 2 thin line below the 30. Next, 15.5 to 43. Well, 10.5 to 43. So 10.5, 43. And next, final one, 13.5 to 50. 13.5 to 50, so 14 will be about here. And 13.5, midway between 12 and 13. Alright, so the graph should look like that. Something resembling that. Let's move to part C. The data given in the table below represents a sample of the number of hours delivery truck drivers worked over a period of 1 week. Calculate the mean. So we know the formula for mean is sum of fx over n, or sum of f. And of course, the number of hours would be our x, and frequency on the other side. So sum of fx, beginning from across here. So sum of fx, f times x. So 1 times 12, or 12 times 1, the order is not important, plus 5 times 32. 5 times 32 plus 7 times 35 plus 8 times 38 plus 5 times 42. I'll enter these in the calculator. In the denominator is the number of delivery truck drivers. So we add up the frequencies, and so we add 1 and 5, 6 and 7, 13, and 5, 21, and 5, 26. That's 26. So the numerator works out to be, and divide by 26, we get 35.81 hours. We refer to column mean x bar, right? Symbol for sample mean there. The median number of hours. So the median. So we know we have 26. We have 26 values, right? So the median, in terms of the median position, let's work out the median position. So the position for the median is n plus 1 over 2. Alright, so n is 26. This is 26. So n plus 1, that's 26 plus 1. That's 27 divided by 2. That's 13.5. So the median is found between the 13th and the 14th value. So the 13th value, so we have 12. The 13th value, so we have 12 1 time, 32 5 times. That's 6 numbers gone so far. And these 7 numbers, so 1 and 5, 6, 6 and 7, 13. So the 13th number would be 35. And the 14th number would be 38. So the median will be average of 35, which is the 13th number, plus 38, which is the 14th number. Add these two values and divide by 2. We end up with 36.5. So the median is 36.5 hours. Another thing I could have done is actually write it out. So 12 occurred 1 time. 32, a frequency of 5 times. So 32, you write 32 5 times. 35 occurs 7 times. So 35 7 times. And on. And you'll recognize that 35 is the 13th value. Or the final, the 7th, so 35, you write it 7 times, right? 1, 2, 3, 4, 5, 6, 7. And then the 14th number now, of course, you'll write 38 8 times. So the 14th number will be 38. And you continue like that. So the median will be between the 13th and the 14th value. Alright. Standard deviation. Let's calculate the standard deviation. So I need to extend my table. So remember the formula for standard deviation is the square root of the summation of a frequency x minus x bar square over n minus 1. And of course we know n is 26. Alright, let's get the column for f times x minus x bar. So first I need to do a x minus x bar column. So let me just extend this table. Let's extend this table. So make some space. So remember x bar was our mean. So to get the x minus x bar column, we're going to subtract x bar from the x values and square the result. So the first one is 12 minus 35.81. Square the result, we'll get 566.92. Next, 32 minus 35.81. We'll get 14.52. And 35 minus 35.81. Square the result, we'll get 0.66. 38 minus 35.81. Square the result, we get 4.8. 42 minus 35.81. Square the result, we get 38.32. We also need f times x minus x bar, and we'll get that by multiplying the frequencies times the column we just completed. So now for frequencies times x minus x bar. So the first one, 1 times 566.92, that's 566.92. 5 times 14.52, that's 72.6. 7 times 0.66, that's 4.62. 8 times 4.8, that's 38.4. 5 times 38.2, that's 191.6. So we need the summation of all our values here in the f, this final column here, f times x minus x bar square. So we add all of these values, we get 874.14. So this value is 874.14 over n is 26, or 26 minus 1, so over 25. So this gives us 34.97, so the square root of 34.97, and that's equal to 5.9 hours. Comment on the skewness of the data using your calculated values and the information in the table. You must use evidence to support your answer. So you remember that the median 36.5 was greater than the mean, so that's a negatively skewed data. So notice, so since the median is greater than the mean, the data is negatively skewed. State one advantage and one disadvantage of using each of the following graphs or charts to analyze data. So pie chart, think about the pie chart. One of the advantage about the pie chart, so one of the pros for the pie chart is that it's visually appealing. When compared to others. One of the cons is, our disadvantage is that the exact values are not revealed. An advantage for the bar graph one of the pros large data set can be easily summarized a disadvantage is that data can be manipulated to give a false impression, and this can be done by using some ridiculous scales to show a wide gap between the different categories. Stem and leaf, obvious advantage is that specific values are displayed, so specific or exact values are displayed. Disadvantage, it's impractical for large data sets. Because since you're showing the specific values, then it's very impractical if you have a large set of data with tons of numbers. Alright, part B. The following stem and leaf diagram shows annual salaries of 25 male workers and 25 female workers at a toy factory. And we have the data here, and we're given the key. So 23/5 represents 23,500. Alright, calculate estimates of all the quartiles for the male workers. So we're analyzing the left side of the table, and in terms of the quartiles, so we want Q1, Q2, Q3. So first quartile, let's call the first quartile Q1. Now the position for Q1, the position for Q1 is n plus 1 over 4. Now n is 25 male workers, or 25 plus 1 divided by 4. That's 26 divided by 4. That's 6.5. So the median, the Q1, the first quartile, is found between the 6th number and the 7th number. So the 6th number, let's count, so 1, 2, 3, 4, 5, 6. So the 6th number, this number is 22,400 based on the key we are given. And the 7th number is 22,500. So we average these, so add them, divide by 2, we end up with 22,450. Let's find Q2, our second quartile. So Q2, same as the median, and the median position is n plus 1 divided by 2. Now again, n is 25 and 1, 26 divided by 2, so 13. So the median is the 13th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is 23,700. That's the 13th number. And Q3, the third quartile, and the formula for the third quartile is 3/4 times n plus 1. Of course, n was 25 and 1, that's 26, so it's 3/4 times 26, That gives us 19.5. So the third quartile is found between the 19th and the 20th value. So remember the 7th was the 13th value. So 13, 14, 15, 16, 17, 18, 19. So the 19th number is 24,100 and the 20th number is 24,200. So we average these, so 24,100 plus 24,200. Add these, divided by 2. So Q3 would be 24,150. So Q1, Q2, and Q3. Next, we're told the box and whisker plot below shows the salaries for the female workers. So for the female workers, we're given the box and whisker plot. And we're asked now to, using the same scale that was used to draw the box and whisker plot to represent salaries of female workers, draw a box and whisker plot on the grid to represent the data and salaries for all male workers in the stem and leaf. So for the male workers, we know for the male workers, the smallest value was 20,300 and the largest value was 25,500. So if you notice the key was each value is in what we call thousands. So 20,300 divided by 1,000, that's so 20.3. We'll plot 20.3 on the graph and 25.5. The scale, so 21 would be here, 23. Well, 23 and 25. So 20. So based on the scale here, each thin line would represent 0.1. So 20.3. So 20. And we'll go 3 thin line here. So 20.3 would be about there. That's the range we're taking care of. And the largest value will be 25.5. So 25.5. 25.5 would be midway between 25 and 26. So that's a range taken care of. The quartiles now. So Q1 was 22,450. So 22.4. So Q1 would be 22.45. So 22.45 would be about here. Remember, this was 23. Don't look at this, was 23. So 22.45 will be just 0.5 short of the 22.5. Q2, which was 23,700. So 23.7. So 23, 2 thin line after the 23.5. And Q3 was 24.15. 24,150. So 24.15. That's 24.1.2. So it's just between 0.1 and 0.2. So remember, the box should have the quartiles. So let me just, so it should look something like that. So of course, you'll be using a ruler. Alright, so the box. And then, so it should something resembling that. And the first quartile, the second quartile, Q2 are the median in the middle, and then you extend your whiskers. Alright, so this should be smallest number, lowest number, highest value, Q1. So the quartiles are in the box, so Q1, Q2, Q3. So it's Q1, Q2, Q3. Using the box and whisker plot drawn for male salaries, determine whether salary of 25,400 is an outlier for male salaries. You must give one reason to support your answer. So, to get the outlier, we need to find the interquartile range. So the interquartile range for the male salaries, Q3 minus Q1. So remember, Q3 was for the males, Q3 was 24,150 and Q1 was 22,450. So we're finding 1.5 of interquartile. Let's find it first. So 24,150 minus 1,700. So we need to find 1.5 now of the interquartile range. So 1.5. So 1.5 times 1,700. We end up with 2,550. Alright, so we're going to add 2,000 to 2,550. So we're going to add 2,550 to Q3. So Q3 plus 1.5 times the interquartile range. So remember, Q3 was 24,150. Plus 1.5 IQ, 1.5 interquartile range, so add 2,550. And we end up with, so 24,150 plus 2,550, we end up with 26,700. So it means therefore that a salary of 25,400 is an outlier since it is, no, it is not. It is not an outlier. For it to be an outlier, it has to be greater than this value. Q3 plus 1.5 IQ. So since it's less, since it is less than, well, let's use the symbol, less than 26,700. Part 4, using the box and whisker plot for male records and female records, state whether male or female records have the better salary. So just by a glance at the diagrams here, both of them, both plots on the same scale and the same graph, notice the male plot is further to the right. Alright, so just by a simple glance we can see that the male records have a better salary. Let's move on to part C. Barnhouse coffee is sold in packets. As a part of their quality control, the manufacturers measure the masses of a random sample of packets of coffee. The indication of good quality is an investigation which yields a mean of 249 grams and a standard deviation of 3.8 grams. The results of an investigation done with a random sample of 90 packets are shown in the table. Calculate an estimate of the mean mass of the coffee packets. So mean. So let's calculate the mean. So we need the mid-interval. So let's do the mid-intervals. And let me put them in the red. So get the mid-interval. What we're going to use for x, by the way, is the mid-intervals. And we'll get the mid by adding the upper and lower limit and dividing by 2. So 240 and 245 divided by 2. That's 242.5. 245 and 248 divided by 5. That's 246.5. And we'll continue the same, adding upper and lower limit dividing by 2. So the mean, sum of fx over the sum of the frequencies. So the mean, so f times x, so 8 times the mid-interval there, so 8 times 242.5 plus 15 times 246.5 plus 35 times 250 plus 23 times 253.5 plus 9 times 257.5 divided by the sum of the frequencies, which is 90. So n is 90. So pause and do the calculation. I got for the mean 250.39, and the unit there was the grams, right? Next, we're asked to calculate standard deviation. So now the standard deviation formula is square root summation f times x minus x bar square over n minus 1. So we need to calculate the summation for f times x minus x bar square. Let's come back to here. So we need x minus x bar square. So we need x minus x bar square. So we have here for this x minus x bar all square. Now x bar was a mean, which was 250.39, and x would be the mid-intervals we have in the red there. So the first one, 242 minus the mean, which was 250.39. So remember x bar was 250.39, right? So the first one, so 242.5 minus 250.39, we square the result, we get 62.41. Next, 246.5 minus 250.39, square the result, we get 15.21. 250 minus 250.39, square the result, we get 0.16. Next, 253.5 minus the mean, square the result, we get 9.61. And the final one, 50.41. And then now the final column, the frequencies times x minus x bar square. So the third column times the first column. So 8 times 62.41, that's 499.28. 15 times 15.21, 228.15. 35 times 0.16, it's 5.6, and so on. So our final value is 453.69. We need the summation. So let's sum these values in the final column. We'll get 1407.75. So in calculating standard deviation, this value is 1407 over n. I remember n was 90, so 90 minus 1, that's 89. So that's the square root of 15.82 equal to 3.98, and remember the unit was grams. Using the information presented in the table on page 14 and your calculations, state if the batch of coffee would be considered a good batch. Give one reason to support your response. No calculations are required. So a good batch would mean that the mean is roughly 249 and a standard deviation of 3.8. We found our mean to be 250.39, which is pretty close to 250.39. 249 is pretty close to the mean we calculated in grams, and the standard deviation, our standard deviation was 3.98. The acceptable standard deviation was 3.8. I don't think there's a great difference there, so I would conclude that the batch was a good batch. Since the values we calculate, it didn't deviate or vary too much from what a good batch is meant to be. 249 grams for the mean, 3.8 grams for the standard deviation. Question 3. Describe each of the following events. Exhaustive events. So events are exhaustive if at least one event has to occur. So for example, if you toss a coin, heads and tails are exhaustive. Since if you toss a coin, it has to be either heads or tails. If you roll a dice, 1, 2, 3, 4, 5, 6 are exhaustive, since one of those numbers has to occur. At least one of those has to occur. Events are mutually exclusive if they cannot occur at the same time. So two events are mutually exclusive if they cannot happen or occur at the same time. Independent. Two events are independent if the occurrence of one event does not affect or influence the occurrence of the other. And you see him time tossing again. Toss on a coin 10 times. Each time you toss that coin, whether you get a heads or tails before that, then tossing again doesn't affect the result, whether it's heads or tails. Alright, part B. Let x be the random variable representing the number of particles in the air with a variance of 36 and a mean of 40. Find the variance of 3x minus 4, so that's a linear expression there. So the variance of a linear expression there, ax plus b, is equal to a squared times the variance of x. So in this case, a would be represent the positive 3. So this would be 3 squared times the variance of x, which would be 9. 3 squared is 9. And the variance of x, we're told, is 36. So it's 9 times 36. 9 times 36 is 324. So the mean doesn't come into play any at all there. A spin bowler on a cricket team bowls using two techniques, half break and leg break. The probability of him bowling a half break and getting a wicket is 0.8, and the probability of him bowling a leg break and getting a wicket is 0.4. On average, 16 of the 24 balls are half breaks and the other 8 are leg breaks. So let's do a graph diagram to represent this. Draw a fully labeled tree diagram. So this bowler bowl two types of ball, right? So in bowl half break. So let me use H to represent half break. And let me use L to represent leg break. So half break, 16 of the 24 balls are half break. So 16 out of 24 are half breaks. And the other 8 are leg breaks. So 8 out of 24 are leg breaks. And of course, we could reduce these fractions. 8 over 24, that's a third. I mean, this would be 2/3. So 2/3 for half break, 1/3 for leg break. Let me just use the simplified fractions. 2/3 and 1/3. Alright, so if in bowl a half break, he can get a wicket. So this is, so him can get a wicket, or him can get no wicket. And likewise, from the leg break, the result could be a wicket or no wicket. Alright, so let's read carefully again. So the probability of him bowling a half break and getting a wicket is 0.8. So half break and getting a wicket, that's 0.8. So 0.8, that's 8 out of 10, right? Or we can reduce it to 4/5. But anyway, 8 out of 10. And the probability of him bowling a leg break and getting a wicket is 4 out of 10. So remember, these must add to 1. So if it's 8 out of 10, no wicket would be 2 out of 10. If it's 4 out of 10, no wicket would be 6 out of 10. So let's complete our diagram by multiplying along the branches. So 2/3 times 8 over 10, that's what? 16 over 30. 2/3 times 2 out of 10, that's 4 over 30. 1/3 times 4 over 10, that's 4 over 30. And 1/3 times 6 over 10, that's 6 over 30. Alright, so diagram completed. So the question asks us, determine the probability that the bowler will get a wicket for any ball he bowls. So the probability that he get a wicket for any ball he bowls. So wicket, these are the situations for wicket. So wicket for any ball would be 16 out of 30 and 4 out of 30. So we add these values. So the chance of getting a wicket, whether it's leg break or half break, is 16 over 30 plus 4 over 30. That would be 20 over 30. So the probability for get a wicket will be 20 over 30. Or 2/3 if we reduce this fraction. Determine the probability that the bowler does not get a wicket given that he bowls a half break. So if he bowls a half break, the chance him don't get a wicket would be, so half break, no wicket, this would be 4 out of 30. So the solution for this probability 4 out of 30. If we reduce it, 2 out of 15. Part C, state one suggestion that the coach of the cricket team could offer to the bowler for successful bowling. You must give a reason for your answer. So success, of course, would mean taking wickets. So if I was the coach, if I were the coach, notice the chance of getting a wicket. The greater chance of getting a wicket is when half breaks are bowled. So half breaks on wicket, 16 out of 30. Leg break on wicket, 4 out of 30. So the chance of getting a wicket is greater when half breaks are bowled. So I would encourage the bowler to bowl half breaks. Bowl half breaks. And the obvious reason is that the chance of getting a wicket is greater. So the probability of a wicket is greater than when leg breaks are bowled. Justifiable events in this scenario would not be considered as independent events. Events are, if we know A and V are independent, if the probability of A intersect B equal the probability of A times is not equal to probability of A intersect B is equal to the probability of A times the probability of B. So we know events are independent if this is the case. Let's apply the context of this situation here. So we can look at the probability of half break on the wicket. So the probability of half break on the wicket is 16 out of 30. The probability of a half break, or the probability of half break again, probability of half break was 2/3, and the probability of a wicket was also 2/3, 20 out of 30. So probability of half break, 2/3, and the probability of a wicket was these two values, 20 out of 30, also 2/3. So the probability of half break was 2/3, and the probability of a wicket was also 2/3. So if you multiply the probability of a half break times the probability of a wicket, what you will get is 2/3 times 1/3. That's 2/3 times 3rd. 2/3 times 2/3. That's 4 9s. And notice this is not equal to the probability of half break on the wicket, which is 16 over 30. So therefore, not independent.